Magnitude of vectors. The length of a vector is called its magnitude. The orientation of a vector, that is, which way it points, is called its direction and is represented by theta, which is the direction of u. For this course, we will focus on magnitude. So here's our vector u. The magnitude is this, and here's our angle theta. After a vector is broken down into its component forces, the magnitude of the vector can be calculated using a variation of the Pythagorean theorem. So our symbol here is u, with the bars on either side, equals the magnitude, that is the length of u, the vector u, and the magnitude of u is going to be the square root of the square of the magnitude of ux plus the square of the magnitude of uy. Find the magnitude of the vector below, where u sub x is equal to 8 and u sub y is equal to 6. The answer is on the next slide. So u sub x is down over here. So that's 1, 2, 3, 4, 5, 6, 7, 8. And that's this term right over here, u sub x, and we have to square it. U sub y is 6. 1, 2, 3, 4, 5, 6. So we square that, add it to 8 squared, and then take the square root, and we get 10 units. And that is the magnitude of the vector u. All of these vectors have the same magnitude. They all have the same length. But vector b, that's over here, is anti-parallel to vectors a1 and a2. a1 and a2 are the same. They have the same length and they're pointing in the same direction. And vector b is denoted as vectors negative a1 and negative a2. Vectors are also represented by bold type, which we're showing over here. The negative of a vector is defined as the vector that gives 0 when added to the original vector. The negative of vector a1 is negative a1, and here's our anti-parallel. Vector b is equal to minus vector a1 and minus vector a2. Two vectors are parallel if they can be expressed as scalar multiples of each other, or if a2 is equal to ka1, then a1 and a2 are parallel. So here's our vector a1, here's our vector a2. They have the same direction, which is important, and they are scalar multiples of each other. So P1, P2, that's this vector here, is parallel to P3, P4. If two vectors are parallel and have the same magnitude, such as P1, P2 is parallel to P3, P4. Okay, what is that? Well, here's P1, here's P2, so that's the first vector. Here's the other vector, P3 to P4. And if the magnitude of A1 is equal to the magnitude of a2, then vector a1 is equal to vector a2. Two vectors are equal if they have the same magnitude and the same direction. A vector may be translated as long as its orientation isn't changed without affecting the vector. If a vector is rotated, it becomes a new vector since its direction changes. A plane is traveling with an eastern component of 40 miles and a northern component of 75 miles every hour. Draw a representation of this. Include the vector of the plane's actual path. And B, what is the plane's magnitude after 1 hour? So here's our plane. It's traveling 40 miles east, so we draw that to the right. And then we go tip to tail to find out that the northern component is 75 miles every hour. And here, this dashed line, that is the actual path of the airplane. So the plane's magnitude after 1 hour is, we're going to call this u, this is vector u, the square root of 40 squared plus 75 squared, and we get 85 miles.